Welcome to the flight video for Flight 7 of the Hakan Super Lancair. The trailing cone wins again.
Stall started essentially right here. It moved here.
The hose for the trailing cone.
Here, and it went like this.
The alternate static.
So much control, it's fantastic.
Super.
Got a long ways to go today, so I'm going to jump right into it. Flight 7 was actually really valuable for two reasons. On one side, it forced us to really talk about the actual mission for the airplane, trying to rein in the vast matrix of questions that are on the table. And on the other side, it allowed us to validate some of the data from previous flights.
1, 2, 3, 4, 5, 6.
Let's get right to it. Maintenance performed. Aileron VGs.
Aileron VGs.
Wing body VGs.
Yes.
H-stab VGs.
Yes.
More tufting.
More tufting.
Static location back to stock. This is the old static part here, so just forward of the trailing edge of the wing. This is the new trailing port, or sorry, static port as installed per the plans from Lancair, which matches the CFD that Hakan did before this flight. With the airspeed indication anomalies from Flight 6, Hakan took the time to redo the CFD he had previously done on the airplane, but this time looking at static pressure variation with angle of attack change as well as flap deployment. With this CFD work, he was able to validate the work that Lance had already done, positioning the static port originally, which he found a very narrow band of real estate on the side of the fuselage where the static pressure didn't vary. It's actually very narrow. Transponder antenna, no, transponder, altitude and quarter.
Altitude and quarter. And then gap seals on...
Oh, right.
Yeah, on both. Canopy seal, but I don't think that matters.
Static overhaul.
Sure. Yes.
Static valve new. So besides the static system in general being a concern on Flight 6, there's also a moment in the video, if you go back and watch it, where we tried the alternate static. The alternate static just vents into the cockpit, but when you move that valve, you saw no difference in the static pressure.
Did you try the alternate static?
You can do that right now, sure. No change.
Okay.
So Hakan went back and looked at the entire static system and found not only the error in the static location, which we already talked about, but he also found that there was leaks sort of all through the system. So he replaced all those hoses, made sure everything was nice and tight, and then replaced the actual valve.
Should we do a 10-inch manifold stall test at the end of the session? Because I don't know if you saw Chris's diagram there, that stall speed went down like 6 knots.
So the Chris that Hakan mentions there is Chris Zavitson. I apologize, I'm not sure how to say his name. He's got a Lancair 360 that he's done some similar work with. The two plots that Hakan is specifically talking about here are angle of attack versus power setting, and indicated stall speed versus power setting. And the point that he's making is that Chris found that if you had the engine at full idle and you measured peak angle of attack versus at some sort of a neutral power setting, that the airplane would actually stall at a lower speed with the engine off the idle stop, which forced us to bring the whole conversation back to mission.
My objectives with this project was to maintain a cruise speed of about 190 knots, but I wanted to lower the stall speed about 55 knots.
And I think what's important there is he said stall speed. So you can see the next part of this conversation with Hakan is us trying to figure out what is the actual mission. Is it stall speed, which especially with two engineers, both excited about doing cool stuff with airplanes, can become very academic, or is it something more practical? Our objective is landing speed, which means landing condition.
Yes.
So gears down, flaps full or full-ish, and then do you think cracked throttle is more representative for an approach?
Well, I need to ask you that. How do you fly it? You don't.
Well, I've only done.
Idle it in. You fly it in, right?
I'm only doing flaps up approaches, and we have a serious glide slope problem. So,
That's true.
right? So as soon as we have, if those flaps do what they're supposed to do, I'm going to have no problem getting on glide slope or getting making the landing from well above glide slope, right? And if that's the case, then the throttle would probably be cracked. But right now, I'm at full RPM, closed throttle, just trying to come down.
Interesting.
So real quick from the top, just so I'm not losing anybody. I know most of the audience is keeping up, just in case you aren't. Let's say this is our airplane. Let's assume it's got a propeller in the front. Obviously, this version's a jet. We're not going to worry. If the propeller is freewheeling, how many seas? Right, especially at high RPM, in order for the propeller to turn, because there's drag in the propeller and there's drag in the engine, it has to take energy from somewhere. And so where it's taking that energy from is the free stream that's going to go over the fuselage. If you were to measure the airspeed of the airplane here versus, say, in the prop wash, there's going to be a delta. And where that works out is that the air going over the inboard portion of the wing and over the horizontal tail is going slightly slower relative to the airplane than the air outboard. And so what we're talking about here is if you just crack the power just a little bit, then there's more air blowing over the tail, there's more air blowing over the inboard wing, which means you can now drive the nose to a higher AOA or a slower stall speed before the airplane does its stall thing. 100% true, 100%. And this is also why in past neutral thrust to full power, a power on stall is typically a much higher angle of attack, probably a lower stall speed. But the whole thing here is what's the mission, right? So outside of the academics of us being dorks and wanting to see what makes the airplane fly different, what do we actually need? So the discussion here is about what do we need for a landing. The standard approach is a 3-degree glide slope. In this situation, as we move sort of away from sort of a certifiable airplane stuff to, in this case, sort of more like STOL or like backcountry flying, the glide slope becomes important in that there may be a tree at the end of the runway. Right? So if you have a relatively short strip, right, but there's a tree at the end of the runway, the steeper you can make your glide slope, the more of that runway you can use to get stopped. So now using a 3-degree glide slope maybe isn't as valuable as having a 6-degree or 10-degree. At some point you get on the other side of it, right, where there's so much vertical component to the airplane. You're not actually flying at 1.3 times the stall speed, right? You're actually flying faster than that in order to have enough energy to flare and stop the descent and land. Which is why this discussion is so interesting, right? Because it's not just about the academic, what is the CL max of the wing? It's much more practical, which is what is the intended purpose of the airplane? Like we talked about earlier, some sort of a top end speed and some sort of bottom end speed. And we can of course drive further. I mean, we can double the wing area and put a parachute on. We can make it go really slow, right?
Both for military and commercial applications.
Right, but you have a goal, and then the high side you have a goal. So let's keep that on the table as expectations. It just hadn't hit me that like this isn't a study of aerodynamics. I mean, it is because we're dorks, but but the goal is an approach, right? And just like we were talking about, if you got a super powerful elevator and you can drive that thing to 45 degrees AOA, but it won't. Like lateral directional doesn't work, it's just snap rolling. It doesn't actually help, so I think that's important context to take. I have no problem checking that. So we have 2 static configurations. Oh yeah, the static system. So there was a bunch of questions after Flight 6, some of which could have been answered if we just had a simple pitot static indication problem. So we went through the flight data and it turned out there was actually a moment in the flight where we did 2 opposing passes, flying stalls in both directions in the same configuration. So the first question looking at the data was, are the GPS speeds legible, right? So that's the helmet cam. It's sort of my last ditch when I'm trying to recover data that otherwise would have been lost from a flight. And there's all sorts of glare issues and whether the helmet's pointed in the right direction, yada, yada, yada. But it looked like we have data in both directions. The numbers are legible. And looking at that data, looking at the true airspeed conversion for the altitude that we were at, it appeared that the indicated airspeed was actually likely wrong based on this very small data point. So one of the big priorities for Flight 7 was we wanted to do whatever we could to get some more confidence in the pitot static system. And there was 2 ways we were going to do that. First being GPS calibration methods or like a clover lead, and the second a static cone. So what's a trailing cone? Trailing cone is actually called out in AC 23-8C. It's something we covered at test pilot school. It's something that we've done on previous programs. And what it really comes down to is it's a way to get a static source that's suspended below the airplane and behind the airplane far enough that you're away from the bow wave of the air going around the airplane. So since most pitot-static air is not from the pitot tube, but from the static system, by taking that static source, instead of putting it on the side of the fuselage where there's all sorts of pressure stuff going on, by putting it well behind the airplane, you have a better chance of being closer to the actual ambient static pressure. We can very much shrink the matrix of the stalls performed as far as flap configuration. The last problem here is that both the trailing cone, but especially the GPS cloverleaf, take time, right? So on the previous flight, on flight 6, we had flown it, 10 degrees flaps, 15, 20, 25, 30, 35. Right now we're gonna add 45. If you take all those flap configurations, do a trailing cone, 2 different static positions, and you do the GPS cloverleaf, you're talking about adding a lot of flight time. Is it just clean and full, or do you wanna have an intermediate? All right, the reason I look distracted is I wanna capture what you're doing with your hand. Okay. So you're saying there's a concern with between 35 and 45 closing up the gap?
Yeah, so the flap is optimized the way it is at 45 degrees, right? So when you pull it up to 35, which is roughly about that, right? Now you see that the slat section is sort of inboard of the trailing edge, which means that it doesn't have the acceleration of the airflow it needs in order to function properly. So the idea that if it doesn't work, what we're going to do is we're going to keep this position of the flap and rotate it up to 35 here.
Got it.
But I will have a 45 in there as well on the tracks, just in case, well, whatever. But this point here is probably going to remain the same, so it's just going to rotate around that line here down another 10 degrees or something. But right now, like I said, it's optimized for 45, and 35 is just an intermediate one. So I probably should have thought about that when I designed it.
You thought about plane, don't worry about it. Do you want to include 35, so 35 and 45 in clean? Yeah. So okay, so there's 3 flap configurations we're checking. So what I'm trying to think here is we're gonna have to build a matrix. I think we talked about checking the GPS speed. If that's still on the table, then we would want to check it in each of the 3 configurations at 1.3 VS. So a cloverleaf is basically a pattern you fly in the sky so that you hit the intended configuration from multiple headings, because you're using ground speed to assume true airspeed. Fly a bunch of different headings, and by doing so you get an idea of what the air mass is doing. You make the assumption that on all the passes the winds were the same, and now you have some idea what the actual true airspeed was as opposed to just the ground speed. So we would drive to 45, to a stall at 45, establish what VS O is, and then 1.3 times that would be our triangle to go fly a GPS heading. We use 1.3 VS because it's sort of the minimum repeatable airspeed that you can fly at for a long time. So 1.3 times stall speed. 50 knots is the stall speed, that's 65. Typically GPS is getting data on sort of the 1 hertz, so 1 time a second, maybe 2 time a second range. So you have to sit there for a while. If you're trying to get GPS speed at stall speed, right? The airplane's just hanging on there by a thread, your airspeed's gonna be varying, you're gonna be trying to drop a wing, etc. So the closer you get to stall speed, the less reliable the data is. The reason you use 1.3 is because it gets you far enough from stall speed that the airplane's repeatably flying well enough to get confidence that you're actually at the intended speed, 1.3, when you read the speed off the GPS in the cockpit. 1.3, 35, and then 1.3 clean to fill in that matrix. Yep. And then we'd have all the GPS data and all the trailing cone. We couldn't get any more data there. 3 different headings, and we would use the suction gauge. Is the DG functional?
So you were idling at the time.
Of course.
When it's idling, it shows 0. A little bit full throttle, and it just comes to life.
How's this work again? Explain this to me one more time. Got it. Okay. And then the last thing is, I would think just a handful of stalls for statistic repeatability at each of the configurations that we're interested in, which is going to be clean, 35, and 45. So we never explained how we installed the trailing cone. For the Thorpe program, we had installed the hose for the trailing cone across the top of the vertical tail. For the Lancair program, we decided to go off the bottom of the tail cone just because it was the most direct route. So the gauge is inside the cockpit. You got to get through the fuselage wall somewhere. How are we going to get through the OML of the airplane, right? Just move of the day, all credit to Hakan. This is the old static port that we just briefed. Hakan came up with the great idea of using the old retired static port. Gives us a hole through the OMLs. Perfect. The other difference was that we weren't going to be able to rely on a nice mechanical connection like an Adel clamp. And then we're using these Adel clamps to hold the tube down on the top of the vertical. Hakan and I decided that it made sense to use Gorilla Tape to attach the very aft portion at the very back of the tail. And then we use glider tape to hold that hose. Okay, so here we have the hose, which we haven't installed yet in the fuselage. Comes out to the old static port. This is the new static port. Down the side of the fuselage. Down the belly. And we're using the extra strong Gorilla Tape. Here's the tail. And then the hose, the probe, and the drag chute. And then we use the alternate static air valve to switch between ship static, which was the new stock static port, and the trailing cone.
So if you pull that up, see it's red there? That's alternate.
Red.
For the, where it's
Oh,
pointing,
got it,
that's
got it.
alternate. So this would be normal.
Brief mission overview. We're going to take off. We're going to fly off to the north. We're going to clear the 45-degree flaps, both fast and slow. We're going to do some GPS cloverleaf stuff. We're going to do a bunch of stalls at 0, 35, and 45 degrees flaps. We're going to come back in and land. We'll be running the trailing cone today, which is the most interesting part of this brief. So maintenance and ER status, I think we've gone through that enough. Is there anything that we didn't talk about that's coming to mind?
No.
Weight and balance will be the same as the last flight. We're still full of gas? Or
Full gas.
Add gas since I was last
Yep.
year? Okay. Cool. First thing on the list, startup, taxi, and takeoff runway. Exactly what we want to talk about. So just off the phone with the Ramona Tower, they're expecting us to go out as a flight. So I'll call that I have ground vehicle with me.
Okay.
You'll have a handheld in the
Yep.
cockpit with you. And we'll go down to the far end, most
Is
likely.
it 27 or 9?
So the last guy I saw took off to the west, so I would assume that's where we're going. But
Gotcha.
go either way. Doesn't. I think we can handle it either way. I think. You'll follow me out. We'll get down the other runway. Do you think we need to shut down?
I would think we should.
Should shut down. Okay. So I'll pull up as close as I dare to the hold short line and then shut down. We'll have a handheld radio so we know that everybody's safe.
Do you pre-flight first, your mag check and all that kind of stuff?
That's a good question.
I think we should. Oh yeah, do all that stuff so you're. Well, actually,
I think the right procedure is to do it afterwards.
I think you're right.
So that means that I'm there making a whole bunch of noise and you're trying to listen to a handheld to figure out what's going on.
Yeah.
So I'll have it plugged in real good. We'll stay on ground for the run up as you would normally.
Yeah.
But if something happens, I'll saw the throttle off and call you on ground and tell you what's going on there on the ground frequency.
Well, I mean, I can be right behind you anyway, right? So.
You'll be right there, but I'm just thinking like in that moment, right? Like everybody's cocked up, ready to go.
Yeah,
like there's traffic around, right?
Yeah.
So that's a scenario we would have to worry about maybe. And then get done with the run up, then I'll taxi out. So I'll do the switch over to tower,
Yes.
and you'll follow me to tower.
Yeah.
I have a sheet for you.
Mhm.
Frequencies. So you'll follow me over to tower, and then we can talk about whether or not the hose looks like it's working. And what I'm going to want to do is get all the S turns out. So the plane will be sitting there. So this is the hold short line, right? The plane's sitting there.
Yeah.
And we're going to take that line and right with the trailing cone sort of in here. And when I taxi out, I want to at least get the S's out, right?
Yeah.
And ideally, no, sorry, at least get the S's out, and I want the trailing cone on the runway, so the cone to go past the hold short line,
Yep.
minimum, right?
Mhm.
And if that looks like it's working where I can accelerate and go and it's not going to drag through the dust, then that'll be what we're closing the loop on. If I need to go to the far side or whatever, we'll close the loop on that over the radio on tower frequency, which they're going to love.
They're gonna hate us.
Yeah, but I think it'd be pretty clean. So maybe let's make sure we run through that before we get out of here. So,
Yep.
so that'd be the plan there, and then I'll go. And like a last call, like it looks like it's still there after I get airborne and get away from the airport. It would make me feel good.
Yep.
I'm gonna break my promise on this. Instead of doing the whole pre-flight brief, I'm just gonna say, first off, we decided to move the cloverleafs to the end because we were so dependent on video footage for the stalls that I didn't want to have the cameras flame out and lose that footage. And then secondly, the continued discussion from Flight 6 about what are the bailout criteria and what are acceptable minimum controls is continued for the prep for Flight 7, so I'm gonna include that. Mission limits. CHT limit of 440 in the climb, 420 for cruise. Oil temp limit of 215. Expected VSO 57 knots indicated. Is that right?
Yep.
So I changed the VS to 68 because that's what we saw clean the first day. Okay. I'm going to rotate at 83, sure. Flap extension speed, I got rid of the calibration, or the calibrated.
Yep.
So it's just 100 knots. Landing gear speed, got rid of it again, 122. VA, 157 knots. Because it's an aerodynamic thing as much as anything, I left the calibrate on there just because we're doing work there. VNE 235. And then limit load factor, flaps up 3.8, flaps down 2.0. Okay.
Yep.
And then power settings will be, so we haven't touched the prop governor. It over revs to 28. Is 28 acceptable until first power reduction?
Yep.
So then the climb power setting will be wide open black knob and blue knob back to 2500.
Yep.
And then 2500 will be my high power cruise stuff that I do. All the climb stuff, everything will be 2500, but full black knob.
Yep.
So we talked mission limits. So previously we had said that if I can't get the airplane down to 150 without getting within 10% of a control stop, then I bail out. We both had some time to think about it. The risks for this flight are much lower than the last one, but I think it's still on the table. Do you think that's still a reasonable limit? We'd have some time in this scenario. If it's a dynamic thing and it's fast, then I'm going to go for the door.
Sure, absolutely.
150 is going to be sporty, right? I mean,
It's going to be very sporty.
Yeah. And so if it's 150, then I'm approaching it like 170.
Yeah.
And like fucking thing won't barely hold altitude at 170, right? With the jam flaps. So you're coming downhill. Like, that's a really gnarly day.
It is.
Do you think we should revise that?
I mean, if you're in that situation, then all bets are off anyway.
So that's the scenario that, again, the goal for this is not to necessarily be able to predict the actual situation, but just to make sure we're on the same page about what it is. If anything that we're doing with the flaps or whatever pushes the controls to where, in order to hold level, I have to go past 50%, we're going to return to the landing configuration and try to land and go from there.
Yes.
And in the event that we're within 10% of a stop, now we're starting to think about emergency bailout rather than trying to land the airplane. And we can have that conversation on the go, but I think we're both agreeing 170 knot approach is really, really sporty.
Yes, it is. No, I agree.
And you're not going to be able to climb on the far side, so you end up just crashing. You don't even, it's a bad day. Okay. Thank you for that conversation. Bailout altitude, so we had decided it was 4,000 AGL. So we used 5,000 feet last time.
Yeah.
Stick with that today.
Yep.
So out of control below 5,000, I'm going for the door. Any go, no-go items that aren't obvious. If the trailing cone gets bound up in the weeds or something when we're trying to go, then there needs to be sort of an abort point where it's not working and we're holding up traffic, right?
Right.
So you're gonna have the radio on and up, and we're gonna like talk about that if the tower's yelling at me or something. In which case we're gonna pop the canopy open and throw it in the right seat, and I'm gonna get off the runway.
Yes.
Do you have a knife in your pocket? You can just dike off the hose.
Find the green knife, please. The utility knife.
That's probably a good thing to have, just to dike off the hose.
Yes.
And then after the landing, like we should be off and out of the way, but
Yeah.
same deal. We can dike it off if it's an issue.
Yeah.
When I've run the trailing cone before, we've done practice approaches to see like if there's a big crosswind, that the cone is ending up on the runway and you're not dragging it through the weeds where it's going to get a landing light or something like that. Runway light or something like that.
Right.
If the winds stay like this, I don't think that's worth doing. But if you're feeling a lot of gust or whatever, there's no problem. We've got plenty of gas. The thing climbs all right. Like it's not an issue. Just come in and what I'll just do is set up where I think the cone should be still above the ground, but just barely.
Yeah.
And I'll fly the center line and we'll talk about where the cone is relative to me, right?
Gotcha.
And we're just trying to figure out how much should I offset to try to keep the cone on the runway, trying to minimize that risk of ripping the thing off.
Right.
And ripping it off, it's like $24 in the worst case for everything that's sitting there.
Yeah.
Probably more like $5. It's more about damage to the airplane.
Right.
So, or something worse. So some of the most interesting lessons from the Thorpe trailing cone effort were the ground handling stuff, right? We all understand that once you're airborne, you're going to have a trailing cone suspended somewhere behind the airplane. But how do you get the airplane with the trailing cone attached from the hangar out to the runway, and then from the runway to airborne, and then from airborne back down the ground, and then back to the hangar? So first we took the trailing cone, coiled up the hose, and just set it in the cockpit and taxied out to the end of the runway. Because I knew I was going to need some help with that, Hakan came along. We just called as a flight of 2. And we went down to the hold short area. Again, as usual, we pre-coordinated all this stuff with the Ramona Tower, and they were very helpful.
I'm on ground, experimental 320 Hotel Lima with ground chase. We're over at Charcoal Aviation, ready to taxi with whiskey.
Roger, 320 Hotel Lima and flight. I'm on the ground, runway 27 taxi, via Alpha.
Via Alpha for 320 Hotel Lima.
Once we got down to the run-up area, we shut the airplane down, took the hose out of the cockpit, and laid it on the ground.
Sid built.
And Ramona ground from 320 Hotel Lima. We're going to shut down here for a second and configure the trailing cone.
Roger, 320 Hotel Lima, approved.
And I like to lay the hose out in sort of a S-shaped pattern, which minimizes the chances of a knot or something forming as you taxi past the whole short line and out to take off. Nothing feels cooler than walking around in a parachute with a helmet.
I know.
I feel like an absolute dillweed. Then they're like, oh, he's good, he's got a beer bong. So not only is he a dork, but he's drinking. Do you have the handheld?
Yeah, I got it in the car.
Okay. Yeehaw! Once that was done, I got in the airplane, I did the run up, and it was time to call the tower to cross the hold short line.
Ramona Tower, experimental 320 Hotel Lima is with you, hold short at 27 and ready for takeoff.
Metro 320 Hotel Lima, Ramona Tower, flight runway heading for now, runway 27, clear for takeoff.
320 Hotel Lima, clear for takeoff, runway 27, and just to be clear, it's going to be a little bit of delay on the runway here for the trailing cone.
Metro 0 Hotel Lima, that's approved, requested sir, and on departure flight runway heading on required northbound turn.
320 Hotel Lima. And ground you there?
Ground here.
As I crossed the hold short line, Hakan watched to make sure that there weren't any knots forming and the hose laid out real nice. I made sure to dive all the way across the far side of the runway, past the center line, and then come back to maximize the chances that the cone made it onto the runway without cutting the corner and going into the grass where it might get tangled in a landing light or something like that.
Looking good.
Alright, here we go.
Then with a positive call from Hakan on the radio, I stood at the power and took off, and Hakan was there on the handheld to let me know if anything had gone awry.
All good.
This is Pitot ground. Can I taxi back on this frequency? Pitot ground, Ramona Tower. Affirmative, sir. Taxi back to the hangars via Alpha. Thank you.
Radio check.
Ready to check.
Sorry about that. Just chasing an engine thing here.
No problem. Everything okay?
Just trying to decide if the engine's running rough.
Okay. But everything else is fine?
Yeah, everything seems good. Did you see the cone get off all right?
Yes, it came up just fine. You were center line. Everything was just fine. Perfect.
Awesome. Nothing like over preparation. I'm showing 90 knots and extending the flaps. Seems like a lot more pitch authority than the last time, so sorry, more of a change in pitch trim. There's full flaps, accelerating out to 100 knots. Plenty of lateral control. This descent rate is impressive. There's 100 knots. Still got plenty of elevator control. Okay, now I'm at the up trim limit, still carrying back pressure at 80 knots. Okay, there's 75, full up trim, power's off, coming up on 8,000 feet. and we were off the bottom of the chart on that. Flaps coming up. Oh, Hakan, that was a big victory. It's a bummer not being able to hear your voice right now. Okay, back to full power. Flaps are up. I'm going to climb back to 10,000 feet for the stall matrix. Just in case you can hear me, the indicated speed was below readable, right? So below 55. Still had positive control. Still had lateral control, directional control, everything was nice.
Oh, that is super. Below 55, huh? And that was that clean or flaps what?
That was at full flaps. No evidence of elevator stall, so I still had good pitch authority.
Super.
Probably got to within 20% of the app limit.
All right.
I was tempted to just keep doing it because it was so awesome, but the descent rate was pretty impressive. So.
Yeah, I can imagine, but that's good news. Super. Was that with the alternate or cone? Was that with cone or system static?
That was on ship static, so not the trailing cone.
Gotcha.
Oh, that was so awesome, man. Okay, 200 feet to go. I'm going to start with the 45-degree flaps just because that's the most valuable data. I'll do 3 on ship static and then 3 on the cone. All will be power off, prop set to 2500, and we'll do 35 degrees and then clean. Just going to go right to full nose up trim to try to minimize the time because we'll be killing altitude pretty quick. And I'm going to knock off the point at 6,000 feet or above so that if the flaps don't come up, I have a chance to get into the airport. Okay, confirmed that static is set to ship. So we're below 120, gears coming out. And here comes the flaps. Okay, full 45 degrees flaps, full nose up trim, power's coming off.
What is coming off?
Sorry, turn the power off. We're configured for the first stall, 45 degrees flaps.
Roger.
80.
Airplane system.
75. 70. 65. 60. 55. Left wing drop, positive control. There's so much control, it's fantastic.
Super.
Okay, that's...
So we flew the GPS cloverleafs at the flap positions as planned, 0, 35, and 45 degrees flaps. As far as the speeds, we used 1.3 VS, but since the indicated speed was well below the indicated region in the airspeed indicator, we had to kind of do our best for the clean configuration. We ran 75 knots indicated. For the 35 degree flap configuration, we ran 65 knots indicated, and for the 45 degree flap we ran 60 knots indicated. If you look at the footage of the cloverleafs, the airplane was very stable. We probably could have flown closer to the actual indicated stall, maybe brought it down a little bit, but regardless, it gave us what we needed, which was a broad picture of the airspeed indicator error, both for the ship static and for the trailing cone. I'm going to just walk through this table I made real quick. That's just a summary of everything we learned from the GPS calibration. So you see we have a bunch of columns here. This big square here that just says GPS calibration across the top, that's all the calibration work. We're going to work away from left to right. Here are the flap configurations like we talked about. It's clean, 35 and 45. The next one is the ship static. So I flew the point on ship static, and then I would check the trailing cone to see what the delta was. So you can see ship static 75, 65, and 60. So that's just the set point. That's just making the assumption I was able to hit the data point. The next one here is the trailing static. So with clean configuration, the trailing static pretty much matched the ship static. At 35 there was an error, and then at 45 there was a similar error between the ship static and the trailing cone in the back. So we took that data and the headings that we flew and the GPS headings that we flew and plugged it into the plot, making the assumptions I talked about before about the mass of air behaving all constant and the air wind being constant, and that backs out what the true airspeed was for each of those configurations using that triangle that we flew. So you can see that 75 indicated was working out to about 79 true. Of course, that's we're 10,000 feet, so there's some atmospheric stuff to be taken into effect. So we have to go from 79 at 10,000 feet back to indicated, and that's what the column is here to the right. So this is showing that at 75 knots indicated with the flaps up, we were showing 67 knots actually, based on the wind correction that we did with the GPS calibration. Then you see at 35 we were trying to get 65, we were getting 56, and then you see at 45 we were trying to get 60 and we were getting 49. So that's a head scratcher, and I think there's more work to be done. Yeah, so the off the indicator, you said the indication, your question was, is the indication different at 35 versus 45?
Yeah.
It's so far down on the gauge that I couldn't tell a difference.
Right.
To be honest, like I was thinking about it as it was happening, like to get an airspeed indicator that's like accurate from like a science standpoint of accuracy down at it's hard to find something that'll go that low.
It's not. This plane is not designed to fly that speed.
It's like ultralight shit.
Yes, it is.
So I bring it all the way up, and each time it would drop a wing at the very last bit, but it was not dramatic. You know, we're talking like 15, 20 degrees roll off, like not totally like Part 23 certifiable stuff, like not.
So basically what you're saying is that handling now versus Flight 6, that there's a huge difference, both in actual stall, departure, and handling, elevator, aileron kind of thing.
So compared to Flight 6, number one, the airspeed is obviously much lower.
Well, it's probably the same airspeed, but the indication is lower.
Sorry, indicated airspeed is much lower. Number two, there was never a dead band, right? And I was way further back on the stick, but still had positive control in the elevator.
Nice.
Which is cool.
But you didn't bottom out.
It didn't bottom out, but I was further back.
Yes.
Just based on what
Sure.
memory.
Yep.
The when it dropped the wing, both times it went left a couple times and it went right just once. It might have been the other way around. But it was real slow roll off, no big deal. I had plenty of time to get the stick forward and recover.
Nice.
Awesome.
Nice.
It's dramatic from 35 to 45, how much the descent rate goes up.
Yeah.
So I don't know if you noticed, but the first stall at 45 took almost 1,000 feet to get configured and then do the stall. Mm-hmm. At 35, I got them all done before I'd kill 1,000 feet. Wow. All three of them. So then I did the flaps up stalls. the flaps up, it was the most pro rotation I felt. It tried to snap on me twice. And it was, both times was when I was on the trailing cone, which shouldn't make a difference, but both times I was on the trailing cone. And it was like, because I was counting off the speeds, and then you said 55, and I was like, no, shit, it was like 50. I remember you know, check the tapes. But the point was, like, I didn't make the last call because I was like trying to keep it from rolling over on its back.
So the departure is way more aggressive, flaps up. Obviously.
The other side is like, at that point I had done 10 stalls, 12 stalls that were so benign, it was like Cessna benign. So maybe I was just getting sloppy, right?
No, I think you're correct, because what happens is when the flaps comes down, your attitude of the aircraft changes, right?
Sure.
So when the flaps are down, you're loading this portion.
Yeah.
Well, you're loading both portions, but it flies with a different angle of attack, right? So when you fly flaps up, the whole wing goes up another, I would say, 5 degrees. So you're pushing the envelope of the whole wing, right?
As opposed to just the inward tick.
Exactly. So I would say that's pretty normal. It's just something to look for. But that was also the reason that I added a little bit more VGs out here.
Sure.
In case of tip stall,
Well, and that's the monster, right? That's what we're trying to do.
Yeah.
It was disconcerting. It was probably the most nerve-wracking of the whole flight, where those 2 stalls were trying to go. Interesting. So notes, idle on the way out was at 1,000, and on the way back it was at 1,200. So I don't know, I was like dragging the brakes to try to so I don't know what happened there. To that point, every time I pulled the gear up, I think it was right at the end of the travel, all 3 levers went. I don't know if they moved forward and stopped or pull back and stop, but I think the gear's running into the cables, which may be what's holding it off the idle stop. We talked about peak CHT, 410 degrees on climb out.
And number 4, which is surprising.
So it peaked like at first power reduction at 407, like just as I was starting to turn, and I was like, shit, we're back to these cooling issues. Prop back to 2,700, got the nose down, let it accelerate a little bit, and then it started to come off and it was almost down to 400. And then it was making all that racket and pissed off, and so I was just gonna leave it. It won't go too far. So I leaned because it was making so much noise. I'm messing with the mixture, and then CHTs went back up, and that's when I saw 410. So typically peak CHT is like there.
Yeah.
To see peak CHT out there was again an indicator that I was unhappy with the motor. We mentioned the gap seal tape. That could have been what I heard. It was more of a hear than I felt.
That could be it.
But it was like a slap. While that was happening, I was like, okay, is that the hose coming off the bottom of the airplane? Or is it the engine? Is it like, I was like, felt like the exhaust manifold was like hanging and banging into shit, right? So it's something worth looking into.
Huh. Interesting.
I mentioned on the radio that the GPS and the static altitudes were way off. I had put in the wrong barometer setting, so that's on me. We covered the stalls. If you look at the clover leaf, so you're comparing these 2 airspeeds. So clean, no change. 35 flaps, it's like 2 knots pretty consistently. And then it's about just maybe a little bit less, but I wrote down 2 knots at 45. So if there was a flap or static position error before, it's gone.
That's good news.
I'm confident that going forward we can believe the cone.
Yep.
So
that's good. That's
a bunch of messing around, but got some data out of that.
Yeah, that's cool.
Any other stuff? Yeah, you mentioned the landing was hot.
Yep.
I told you I was done, made a couple calls and I didn't hear you, so I said, okay, I'm going over to
No, I didn't know. I didn't hear you switching to tower.
I made like 4 calls, like, hey man, all right, I'm coming down, like, okay, I'm done with stuff, I'm heading back. All right, I'm gonna switch frequencies. Okay.
Didn't hear anything at all.
Okay.
I saw you on the map. It's like, is he going into?
Where's he going? What's he doing?
Yeah. So this looks like he's, you know, on the left base or right base. It's like, and I called you. Yeah, and nothing. Okay, he must have switched.
Huh.
So I switched, and then I heard you were. Yeah, you were.
So
on,
I told the
down
tower
there.
you were going to be down there, and they said they hadn't heard from me. And I was like, well, I'll just do a low pass, and that way you see me, and then you can see the cone. Maybe there's something we learned from that.
Yeah.
So I did that. Descended with gear out all the way from altitude, and then did the pattern with gear out.
Okay.
Came in, and 110 on final is fast.
Bear in mind now that the indication is different from what
Yeah.
you're used to. So it's probably.
If I was going to guess, I would say 90, 95 would have felt like what I would have expected before. So, but I was like, well, you know, we said 100. Like, come on, man, let's do this. So
that was fast. It looked fast.
and I got down and like I'm touching the brakes and just like,
Yes.
come on.
It's like this.
Because I was just thinking about going off the runway.
Right.
And then shutdown, all that stuff was normal. Anything else from your side?
No, it looks good. Takeoff was good. Cone was centered. When you came in for the test run with the cone, it was a little low. And then you pulled up a little bit. And then
Did it drag at all on the?
No, but it was like this far off.
Right.
And it was right at the end of the runway.
Did it look like it was pretty well centered?
It was well centered. It was just probably a little bit too far out, you know. But
It's a long rope, you're saying.
that's the thing.
Yeah.
Right.
Yeah.
But landing was fine, you know. So everything was.
And did it look like it ever hit the dirt when I landed?
No.
Okay. I was looking at all the stuff on the ground. I was like, I don't think there's anything else we can hit. I need to get down.
Right.
That was definitely high. Okay, so plans for another flight.
Starts
So,
right
so,
here.
so we reviewed the tape.
Yeah.
Let's talk about what we saw before and
Yeah.
then what we.
So what it was initially, without the vortex generators and without knowing the speed, but looking at the stall performance, stall started essentially right here, and then it spread in a triangle, like this, all the way out there, and up on the fuselage. So this, essentially, this whole area here was separated, and that also caused a wake that went right into the horizontal tail, and caused a lot of issues right there. And by adding these, stabilizing the flow downstream here, and these downstream of a flow that actually comes right around here, and it perpetuates further back on the fillet. These keep that massive wake away from the tail. Plus, the tail now have a gap seal, both on the upper and the lower, and of course the vortex generators. So the vortex generators by themselves, they do a great job, but I think eliminating that huge wake by keeping these guys, at least for now, I think that is a good thing. Because now, stall moved from here, with the VGs on, it moved here. And it started essentially here, and it went like this. And then you can see this section was stalled later on, and it goes in here. But as far as here and here, it was very stable.
Protected up there.
Yeah. So I think that this did the trick. I think it really did the trick. So what we're going to do, we're going to remove the outboard ones on the tip. I don't think they're necessary. I think that it's good to have, but I don't think they're necessary.
Okay.
We will see when we try it out.
So what I recommend is, so the next flight, the purpose is cruise performance check.
Yes.
But since we're going to fly, I think we should stall.
You should stall.
And I think if we're going to stall, we should have one camera on the tail looking forward.
Yes.
So, but we don't need to have both. So we got rid of 4 out of 5 of the cameras.
Yes.
But we'll leave the Tufts on the whole airplane.
Yep.
But we're getting rid of most of the external cameras. We're getting rid of the trailing cone. We're going to go up and do a performance check and try to get an idea of what the performance hit is from the big VGs.
Yep.
At the wing body fillet. Cool.
I need to check those engine controls